Good morning, class. Okay, we start our class first. Okay, this differentiation, actually, this is kind of a revision to all of you. Okay, because you have learned how to differentiate the trigonometric function, how to differentiate exponential, and also, okay, the related function, it refers to the related function in the exponential function. Okay, that's mean the long function. The trigo, exponential, and long function. Okay, differentiation is used to solve many real-life problems. Okay, and it is important. Derivatives is important in solving engineering and science problems. Actually, there is one subject. I'm not sure this subject is taken in which semester. The subject is dynamic and mechanics. Dynamics and mechanics. Okay, this subject is the failure rate is quite high. Okay, the failure rate is quite high, and the lecturer feedback to me, students do not know how to do differentiation and integration. But actually, after I read the notes given by that lecturer, I found that I don't think students do not know how to differentiate and integrate. The problem lies on students do not understand the problem. When is the time to use the initial values? Okay, when is the ending point? Okay, I think students do not understand that situation. That's why students do not know how to express. Okay, but if given the integration function and the differentiation function, I think all students manage to solve it. Okay, but anyhow, this one after we look at differentiation, because that is more to integration. Integrate acceleration, you get velocity. Integrate velocity, you get distance. You can find for the displacement, all these kind of things. Okay, maybe I will insert that in under the integration. Okay, under integration. Okay. Now we have ahead the schedule. Okay, this is the week 8 syllabus. Okay, this is week 7. Okay, that means after you come back from the next week is miss and break, right? Miss and break. After you come back from miss and break, supposed to be start this, but I will start this one first because I want to insert some element, something from the engineering subject. Okay, insert into this course so that you can have some rough idea before you move to your Sem 2. Okay. So normally derivatives. Okay, normally derivatives. It's common to model the behavior of moving objects, moving distance, velocity, acceleration. Okay, it's very common. So this is the derivative f prime. Okay, in this EM1, you will just expose to single variable. Okay, single independent variable. Okay, you have only x, everything in terms of x. In EM2, Sem 3, okay, you will be introduced with multi-variable. Okay, that means you have function in x, y, in x, y, z. Okay, but now we only focus on single variable. That means function in x. So the derivative of fx is either we write in this way, either in this form f prime fx, or we can write in this one d over dx. This means we differentiate this function with respect to x. Okay. When you see the d over dx, that means we want to differentiate this function with respect to this variable. Okay. So these are the common list of formula. Okay, for the trigonometric functions. You can refer to the past year EM1, past year final exam question, and look at the appendix. Okay, what are the formulas will be given in the appendix? Okay, I think some of the basic one is given. Okay, if not mistaken. I can't remember. You can refer to the past year question. Okay, the appendix. Look at the appendix. What are the formulas given? Okay, and this is the formula for the exponential function. Okay, differentiation of exponential function. Okay, so normally we refer to this one e to the power of fx. Okay, so when we want to differentiate this kind of exponential function, you will get the same function back, but you need to differentiate this and you put it here. Okay, this is how we differentiate the exponential function. Okay, and for the ln function, when we want to differentiate a ln function, this function we put it as the denominator, and we differentiate the denominator with respect to x, and we put it as the numerator. This is how we differentiate ln function. Okay. Okay, this is some hyperbolic functions. Okay, hyperbolic. This is hypersine, hypercos with the extra h here. This is hypertan. Okay, so these are the formula. Okay, this is formula for the hypersine. Okay, so hypersine is actually equals to this one. So when we differentiate this function, okay, we get this, and this is actually the formula of the hypercos. Hypercos. That's why when we differentiate hypersine, we get hypercos. Okay, and this is the hypercos formula. When we differentiate this function with respect to x, this is what we get, and this is the formula for the hypersine. Okay, so when we differentiate hypercos, we get hypersine. When we differentiate hypersine, we get hypercos, similar to the sine and cos function. And the difference is, when we differentiate sine, we get positive cos. When we differentiate cos, we get negative sine. Okay, this one you must remember, this one, the basic one. But for the hyper function, okay, no matter you differentiate hypersine or the hypercos, you get both positive. Okay, hypercos and hypersine. Okay, and when you differentiate hypertan x, you get this hypersecant square. Actually, okay, these are the formulas. Okay, that you can refer to. Okay, this is inverse trigonometric functions. Okay, inverse. That means up sine, up cos, up tan. Okay, these are the formulas. Okay, this one just lists out the formula and want you to do some exercise based on the formula given. Okay, this is the inverse hyperbolic functions. Okay, inverse hyperbolic functions. Differentiation formula. Okay, now we look at the basic rules. Okay, basic rules. This one you just treat it as revision. Okay, revision. Okay, when we have a constant multiplication rule, when we have a function multiplied to a constant, okay, that constant we put it outside. We just differentiate the function in x. Okay, the function in x. Then we get the f prime x. Okay, when we have this one, a linear combination. When we have a linear combination of two functions in x, we differentiate one by one. So you get u prime plus v prime. Okay, no matter plus or minus. Okay, no matter plus or minus. If this is minus, this will be minus. Okay. So we will go through some simple examples. Find dy dx when you have this kind of function. Okay, but actually surprisingly, some of the students, they still do not know or they forgot how to do the differentiation for this function. Okay, okay, so this is a polynomial function. So when we want to differentiate the polynomial function, we will multiply the power to the coefficient. So 4 times 7, you get a 28, and then this power minus 1. Okay, that means 3. Okay, 4 times 7, 28, and the power minus 1. This is for differentiation. Okay, so this one just now, similar to the example just now. So 7 times 4, you get 28. 28, and then this one minus 1, you get 6. Okay, and when we differentiate for exponential function, okay, if you just look at this e negative x, when we differentiate e negative x, we get negative e negative x, right? We get this function back, and we differentiate this one with respect to x, we get a negative 1. Okay, so you get a negative e and negative x. But with the minus here, okay, you have a plus. Okay, you have plus. E negative x. When we want to differentiate this, we get negative e negative x. Okay, you will get this function back. Okay, for exponential, you get this back. But when you differentiate this one, you get a negative one. You have to put it here. Okay, that's fine. The minus, negative, you get a plus. This one. Okay. Okay, product rule and quotient rule. This is one of the formulas where students tend to forget. Okay, product rule. Okay, when we have to use the product rule, when we have the two functions in x. Okay, if we have two functions in x, the product of two functions in x. So a function in x multiplied to another function in x. And when we want to do the differentiation, we have to use this product rule. Okay, this formula, okay, you can either use uv prime plus vu prime or vu prime plus uv prime. Okay, the rule is you copy one, you differentiate another one, and then plus you copy the later, differentiate the previous one. Okay, and quotient rule. Okay, quotient rule, it will always start with the bottom v first. So v u prime minus u v prime and then over v squared. Okay, this is the formula. This will always be minus. Okay, minus. This is for a function in x divided by a function in x, and we want to get the derivatives. Okay. For example, this one e pi x is a function in x. X to the power of 4 is another function in x, and this is function in x times another function in x. So to get the dy dx, we have to use the u. This one, uv. Okay, we use uv. So this one, you can either use this one, uv, okay, u prime, v prime to get their corresponding derivatives. Then you just this one times this one times this. Okay, you sum the two products. Okay, sum of the two products, then you get this. Okay, so this one, okay. Let's say I copy this e pi x. I copy the e pi x. Then I differentiate this one. I get a 4x cubed. Okay, 4x cubed. And then plus, now I copy the x power of 4 and I differentiate exponential function. I get a pi e pi x. Okay, pi e pi x. Okay. So use any way that you prefer. Okay, as long as you get the correct answer. Okay, this is another example, okay, where we have to use the product rule. Okay, a function in x multiplied to another function in x. Okay, this one, okay, x cubed. Let's say I copy x cubed first, x cubed, and then I differentiate ln x. Differentiate ln x, I get 1 over x. Okay, and then plus, now I copy the ln x, and I differentiate the x cubed. So I get 3x squared. Okay, simplify, you get the final answer. Okay. Okay, any questions? Okay, next one, quotient rule. Okay, u over v. Okay, u over v. So for quotient rule, we will start from v. Okay, so v first. So you copy this one, e pi x here, and then you differentiate this one, you get a 4x cubed here, minus, now you copy x to the power of 4, and you differentiate this one, you get a pi e pi x, pi e pi x over v squared. Okay, v squared. So e pi x squared, e pi x squared, that means 2 times pi x. You have 2 pi x. Okay, then here you can factorize the e pi x, factorize e pi x. This is the common mistakes that I found from students. Okay, we factorize the e pi x. So we have 4x cubed minus pi e minus pi x about 4 over e to pi x. Okay, when you have a fraction function, we can only cancel out, and we can only cancel out the function provided this is multiplied to the whole function. Okay. Because normally, what I encountered is students tends to, like 1 over y. Student tends to just cancel out something like this. No, we can't do this. We can't do this because you have to make sure the y should be multiplied to the whole function, then you can cancel out that y. Okay, you can't cancel out one of it. Okay, using this way. Okay, so before you cancel out, you have to make sure the function that you want to cancel out do. Okay, it must be multiplied to the rest of the function in the bracket. Okay, before you cancel out. Okay, so back to this one. This e2 pi x, this is actually e pi x times e pi x. So we can cancel out 1. So at the bottom, you have e pi x. Okay, next. Okay, this is also u over v. U over v. So we start from u. Okay, so copy. Sorry, v is this one. Copy x minus 1. Differentiate cos, you get a negative sign, and then minus. Now we copy the cos x and we differentiate the v over v squared. Okay, so this one we can't do the cancellation because x minus 1, we have x minus 1 at the first term, but we do not have the x minus 1 at the second term. So we can't cancel out the x minus 1. Okay, so just leave it like this. This is the final solution. Okay. Okay, now try this. Okay, the first term you have to use product rule. Okay, product rule. Okay, attendance, well, time for attendance. The first one to use UV. Okay, so we use UV. Okay, product rule. Let's say I copy the first term U, and then I differentiate this. So I get 3E3X. Plus, now I copy this one, and I differentiate this. Okay, this is product rule. Okay, product rule. Copy, differentiate, plus copy now this one, differentiate this one. Okay, and this one, this is just a single function, so we just differentiate directly where the power in the power of -1 multiplied to the 3x and then -1. -1, you get a -2. After you simplify, you get a 3x over 4e3x, 4x cubed e3x minus 3x -2. You can leave it in this one, or you can factorize the x cubed e3x. So 3x plus 4. Proceed number 2, number 3. So this one, we use product rule U V. Okay, U V. We can use this as V because this is not a product function. This is just a function in X. This is another function in X. This is linear combination of two functions in X. Okay, so we can use UV directly. Okay. So let's say I copy and then I differentiate this one. When I differentiate this, I get a 3 cos 3x, okay, plus 5 sine 5x. Then plus, now I differentiate this one. I get a -2. -2 e -2x. Then I copy this. Simplify.
Dia differentiate tu kan dia
3 cos x plus 5 sine 5x minus 2 sine 3x plus 2 cos 5x. Even though if you have a product function here, still we can use the UV, but you need to apply the product rule inside here when you find for the V prime. Okay, what I mean is if you have this kind of function, y equals to x e 2x, let's say ln 3x. If you have this kind of function, how do you find for the dy dx? How do you find for dy dx? There are three. Still, we are using uv. This is your u. This is your v. But when we find for the u prime, okay, this is your u, right? When we find for u prime, this is your uv. That's when you apply the product rule twice to get the dy dx for this question. Okay, any question for number 2? Okay, here I factorize. This to get this. Okay, factorize. Then what is left? Will be here. Okay. And we move to number 3. X plus 1. X to the power 4 minus 3. Okay, so this one is a quotient rule. We have to use quotient rule. U over V. Okay, V first. You have to get V and then U prime. VU prime minus UV prime over V squared. Okay, V first. Okay, V first. V. Okay, V U prime. U prime is 1 minus U V prime. V prime you get 4x cubed over V squared. Okay, so simplify, expand minus 4x about 4 minus 4x cubed Negative 3 minus 3x over 4 minus 4x. Okay, this one you can factorize the negative. Okay, or you can just leave it.
Sini. Apa itu? Pernah itu jadi kalau PDS itu kita ambil tidak kalau kalau yang paling saya cerita kalau bisa impresi pada diferensiasi ini
Number 6 use the product rules. But you can refer the formulas for the inverse polynomial function. That is inverse. The next one is Okay, done. Number 3. Okay. Number 4. Number 4. X log 4x of 5 plus 3. Okay. So this one we use product rule. Product rule UV. Okay, UV. Okay. If you want to write this out, okay, you can write like this. U is x, v is log function. Okay, then find for u prime and v prime. Okay. Okay, differentiate x, we get a 1. Differentiate log function, you will get a fraction function where the functions here, you put it as the denominator. Then you differentiate this one, you get a 20x to the power of 4. You put it at the top. Okay, this is how we differentiate a log function. Okay, differentiate denominator, put it at the top.
Oh,
Okay, so this is okay, copy x, differentiate this one, you get this. And then class, copy the ln function. Then differentiate x. Okay, so you get 20 x to the power 5, 4x to the power 5 plus 3 plus ln. Yang lain nih. Simplify.
Memang menteliti.
Tadi kayaknya.
Kalau tadi kata boleh, itu dah tak boleh mati. Lagi aku dia proses sudah dengan dia.
Kita differentiation. Jalan differentiation.
Kita kerja. Kita kerja. Ya, kemudian masih dia sekarang. Yes. Yang bantu ini harus kita dorong.
Okay, done? Can I round it off? Okay, number 5, you have to use quotient rule. Okay, quotient rule. We use the same way to differentiate the ln 2x. Okay. Okay, quotient rule, u over v. The dy is x. Okay, we have to start from v. Okay, start from v. So this is your v. V u prime. Okay, how to differentiate u prime? How to differentiate ln 2x? 2x. You put it here, right? When you differentiate 2x, you get a 2.
Okay.
Minus, now we copy the ln 2x. Then we differentiate the v, so we get a 6. Okay, over 6x minus 5 squared. Okay, simplify. Okay, so this one we can cast out the 2. So we get 6 minus 5 over x minus 6 ln 2x over 6x minus 5 squared. Okay, so if we want to eliminate the x here, okay, if we want to eliminate the x here, what we do, we multiply x over x. Okay, we don't change the question. Okay, now I just want to eliminate the x here. So we times and x over x. We don't change the question because after canceling out, we just multiply 1. So this means when x multiplied to the whole function here, you get a 6x minus 5 because x divided by x, okay, minus 5. And then minus 6x log 2x over x multiplied to this function, it will be x times 6x minus 5 squared.
Ikan ni apa orang panggil lu? Ikan ni. Dan orang tolak jadi ikan. Ini potong-potongan dia pun tahu kenapa
Okay, if you refer to any of the international reference book, you won't get this as your final answer. They won't leave the answer in this form because this is A over B over C. Okay. Any more questions for number 5?
No. Yeah.
So can I wrap this up?
Yeah.
Okay. And last one. X plus 1. Okay, so this one, a function in X multiplied to another function in X, so we use UV. Okay, UV. So U is X plus 1, V is the hypercos. Okay, this is up hypercos. Okay, up hypercos, not 1 over. So you can find the formula here. This one. Okay, so when you differentiate this function, you get this 1 over 1 times the x squared minus 1. Okay. This is 1. Differentiate plus copy differentiate So these are the basics for derivatives. The common use one, okay, the quotient rule and the product.
Là đừng có đi quả tay rồi này. Là phải sẽ có ăn gì đó. Đi trong cái phân sát này. Anh là có cái có sao. Tapi kalau kita buat ini ada di mana dia yang pada. Buat tadi.
Okay, now
Tapi kan kita juga jadi di pun kita ni dia.
Nah, kok sebab
Okey. Jadi dia tiba-tiba nampak.
we proceed to the next one, chain rule. Chain rule. Have you learned this before, chain rule? The simple one. Okay, this is just extended chain rule. Okay, extended a little bit so you can see more than two. Okay, now we look at this chain rule. If you have a function, okay, w in x, and then y in w, then this is the chain rule. Okay, when we want to find for dy dx, okay, this is what we want, dy dx, but we have one extra w. Okay, this one, you see, actually we can cancel this. Cancel out this one with this one. Then you get a dy dx. Okay, so to get dy dx, okay, we have this dy dx, but we have an extra term of w. Okay, for extended chain rule, okay, dy dx, but we have extra two terms. Okay, you see, when we cancel out the dw, dz, we have dy dx. Okay, we have dy dx. It's just that we have another two variables, w and z, okay, involved in the functions. Okay, we look at the example. Okay, find dy dx when you have this function. Okay, this one, actually, without the chain rule, we can also get the answer. -5, you put it at front, then you have -5 here, and then this one you copy, and then function the power here you -1. Okay, -1 you get -6, right? -6, and then you differentiate this function, and you put it outside. Okay, but this one actually the proper way we are using the chain rule. Okay, chain rule meaning that we let a function to be this 2x squared plus 5. Okay, what we let? We let w. We let this function to be w. Okay, w is 2x squared plus 5. So if this is w, then your y will be w to the power of -5. Okay, w will be y will be w to the power of -5. Okay, so to get the dy dx, okay, we write out dy dx. We have an extra term of w now. Okay, so dy dw dx. Okay, you see these two we can cancel out this dw. Okay, what we yes. Okay, so dy dw you have to get from here dy dw. Okay, differentiate y with respect to w. Okay, so dy dw is -5. You put it in front, and then -5 minus 1, you get -6. Okay, so this is dy dw. And then dw dx. Okay, this one dw dx, that means we are differentiating this one with respect to x. So we get a 4x to the power 1. Okay, then you just substitute these two into the formula dy dx. Sorry, dy dw, this one. dw dx, this one. Okay, so you get this as the answer. But since your question involves only the y and x, so we have to change this w back into y and x. Okay, your final answer should be in x only, this one. Okay, because this is y. Y equals to a function in x. So your x should be function in x. So w is this one. 2x squared plus 5. You just substitute this back into w, then you will get this. Okay, that's me. We use the extra variable w. Okay, we use the extra variable w. Okay, we let this function to be w. Okay, that's why we get this 2. Okay, and to get the dy dx, you have to write this out. Dy dx is dy dw, and then dw dx. Okay, w is the variable that we use to find for dy dx. The final answer will be everything in x, no w. You have to substitute the w back into x. Okay, this is the final answer, not this. This one not yet complete because w is what we insert to our working. It shouldn't be appear at the solution. Okay, so we substitute w back into x. Okay. Next, okay, look at another example. Okay, this one. Exponential to the power of this. Okay, this one, we can let this to be w. Okay, we can let this to be w here. W is x cubed plus 1. So if this is w, that means your y will be EW. Okay. So now we want to find for dy dx. Okay, dy dx. And we insert the extra w. So you have dy dw, dw dx. Okay, you have to know how to write this out. Formula is not given. You have to know dy dx. And when you insert the w, it should be dy dw, dw dx. Okay, where after you cancel out the dw, you should get the dy dx back. Okay, so dy dw, okay, dy dw is EW. Okay, dw dx, dw dx, differentiate this, you get a 3x squared. Okay, then this one times this, but you need to change the w back into x. This one. Okay. Okay, another example. If you have this sine 2 pi t plus 1. Okay, we can let 2 pi t plus 1 to be, okay, here I follow this one, it use u. Okay, we let this to be u. Okay, then our y will be sine u. Okay, we let the function in the bracket to be a new variable. Okay, then we have sine u. So next you have to write this up. We want to find for dy dt. Okay, dy dt. So the new variable is u. So you have dy du and then du dt. Okay, so dy du. We have to find from here dy du. Differentiate y with respect to u, you get cos u. Okay, du dt. Here, du dt. Differentiate this u function with respect to t. So we get 2 pi. Okay, so this one times this, but we have to change the u back into t. Okay, so this one substitute back into this u to get this. Your function, your answer should be in terms of t. Okay, this is in terms of t. Okay, the process is all the same. Okay, now we look at the extended chain rule. When you have a function y equals to ln, inside the ln you have arctan function. Okay, and this arctan function in the bracket you have x squared plus 3x minus 4. So this question we have to solve using extended chain rule, where we let this, okay, here we let this be z. Okay, when this is z, okay, here, when this is z, then you have arctan z, right? You have arctan z. And again, we let the arctan z to be another variable, which is w. Okay, w. So if arctan z is w, you have ln w. Okay. So dy dx, we want to find for dy dx. Okay, so y in terms of w, so dy dw. W in terms of z, dw dz. Z in terms of x, dz dx. And after you write this sequence, you will see this dw, you can cancel out, dz, you can cancel out, you get dy dx eventually. Okay, so now dy dw, dy dw. We differentiate ln w, we get 1 over w. Then dw dz. Okay, dw dz, this one you can find from the list of the formula. When you differentiate arctan z, you get 1 over 1 plus z squared. Okay, and then dz dx. Differentiate this one with respect to x, you get 2x plus 3. Okay, then you just multiply everything and you change the z back into x. Okay, this one, and you change the w, okay, w back into z, and this x, this z, you replace by this. Okay, so that everything should be in x. Okay, any questions? No, I have one question. The example that I gave just now, I give x squared ln what I give just now, exponential function. Let's say I give another. Can this function solve? Can we find the derivative using extended chain rule? Yes or no?
Yes. I don't know.
No. This is function times function. If you look at extended chain rule, there is only one function. This is function inside the function. Right? This is function inside another function, but not function times function. So this is the difference between the extended chain rule, the chain rule, and also the product rule. Product rule is a function multiplied to another function. But for the chain rule, you have only one function, but function inside another function. Okay, try this. Okay, number 1, 2, 3. You can use chain rule. Okay, number 4. It can be chain rule, can be extended chain rule. Okay, this one. Okay. The function inside the bracket, we let it be a new variable. Okay, we let, what do you want to use? W. Okay, we let W to be 5x squared minus 3. So if this is W, then your Y will be W to the power of 1 over 4. Okay, now dy dx, we want to find for dy dx. Okay, so dy dx, okay, actually from here, we can sketch a diagram. Y, you have W. Okay, Y, you have W. W in terms of x. Okay, that's why if you want to find dy dx, you have to find for dy dw and dw dx. Oh, yes, math always makes sense. Okay, so we have this. And again, these are all single variable. Y has only W. W has only X. That's why we all use D only. In EM2, you will see more than one. Okay. EM1, we just have single variable under one. Okay, one. That's why all is D. When you have more than one, that will be delta.
EM2.
Yeah, EM2. Yeah, dy dw is 1 over 4 W and 1 over 4 minus 1. Negative 3 over 4. Okay, then dw dx. dw dx, you have a 10x. Okay, cancel out the 4 and 10, we have 5 over 2. 5 over 2 x and w. W we change back into x. This is a simple example. Actually, without chain rule, we still can solve this without chain rule. Okay, but this one I want you to use chain rule. I want you to solve using chain rule. Okay, because you are learning chain rule now. Okay, just click that. So it's an exercise for chain rule.
You can use
The one we can actually y is 5x. Okay. Actually, this one we can just 104 bring it in front, 5x squared minus 3, this one minus 1, and then times, you differentiate this one, you get 10x, right? Then you get a 5 over 2x, 5x squared minus 3. Okay. This one is by formula. This one by formula. But how we get the formula? From chain rule. Okay, now we look at number 2. Number 2, y is of course 4x plus 3. Okay, that. Okay, now. Okay, in the list of formula, okay, I think the formula will be given something like this. This one, differentiate up cos x, you get negative 1 over third of 1 minus x squared. Okay, so you see, you are given this formula. Okay, look at here, you are given, in the slide, you are given this formula. But when x is no longer x, okay, when x is no longer x, but something like this, then you can apply the chain rule to get the solution. Okay, because formula, if you are given formula only for this x. But when this is no longer x, but a function in x, then you have to apply the chain rule to get the solution. Okay, you can make use of this to get the solution for this one. Okay, because formula is not given to you about this one. Okay, this formula is not given. So you have to know how to use chain rule. Okay, and with the help of this to get the solution. This one is okay. Now we let we use w. We let w to be the function in the bracket. Okay, when this is w, then our y will be cos w. Cos w. So your y has w. This one y has w. W as the function in x. Okay, w is the function in x. So your dy dx. Okay, the dy dx will be dy dw dx. Okay, then point for dalam program.
Masih juga ambil yang dulu kan? Tak ada kelas apa
Okay, DY, DW, that's means we are using this one, right? Okay, we want to differentiate this one, that's means we are using this formula. Okay, it's just that we don't use X, we use W. So when we change X into W, this is what we get, dy dw. And then dw dx is 4.
Yeah.
So you get a negative 4 over 1 minus w squared. Okay.
Tadi nampak dalam kelas tadi.
Okay. Then okay, number 3. Upset.
Kalau macam ni dah kalau dia kena ambil N3X tak boleh.
Okay, this one, what is your W? Number 3, what is your W? Three x plus 2. W. You can't take this as your W only. If this is W, then your Y will be in terms of W and X. We want the W in terms of single variable. So you can't let this to be W because you still have X here. So you let the whole function to be W so that your Y will be upset W. Okay, up there.
One we might want to
Explain. D1 x y dw dx. Okay, to get the dy, dy dw, we have this formula. Okay, dy dw. So this one we change into w, this one change into w, then we get this. Okay, when this is x, dy dx is this one. So when this is w, dy dw will be w with. Okay, dw dx. How to get dw dx? Quotient rule. Quotient rule, because your w is a function in x over another function in x. You have to use quotient rule. So v first times u prime minus u times v prime over v square. Oh, I simplify it. Okay, your W is this one, 3x plus 2 over 2x minus 1. Square. Okay, times, okay, simplify. 6x minus 3 minus 6x minus 4. Okay, so this is 1 plus 3x plus 2 square over 2x minus 1 square times negative 7 over 2x minus 1 square. Okay. We want to multiply, right? We want to multiply. That means negative 7 times 1. And then this one times 1. Then this one times this. When this one times this, that means we can cancel out this one, right? So we can have this 3x plus 2 squared. Okay, I repeat this one. This function multiplies with this. That means Nominator, multiply nominator, you get this. And this function, you have to multiply to this. This function multiply to this, and you have two terms here. So this one multiply to 1, you get this. This term multiply to this, you can cancel out. Get this.
Please apply to the next
This one I don't know how to answer to your question. This one is depends. One is depends. Maybe 5 or 6. If I set the question, this will be 5 or 6.
Okay. Ini sama. Ya.
Okay, next, number 4. Okay, number 4 we use chain rule. Okay, number 4 we use chain rule. That's all. You know how to differentiate the sign for x. Okay. So next one, what is your W?
For x.
Okay. If we use chain rule, okay, if we use chain rule, it will be sign for x. If you use extended chain rule, it will be 4x. Okay, later I show you the extended one. Here I show you the chain rule first. Okay, chain rule, this is W, so your y will be
Y.
non W, right? Non W. Okay, continue from here. Okay, so dy dw. Dy dw you get
1 per W.
1 over W. Okay, dw dx. Differentiate this one with respect to x, you get 4 plus 4x. So you have 4 cos 4x over W sine 4x. Okay, and this one actually we can simplify. Okay, but you can leave it. This is actually cotangent for x. 4 cotangent for x. Cos 4x over sine 4x is cotangent for x. Okay, show you the extended chain rule. Okay, the extended chain rule. If we use the extended chain rule, okay, we let we can have z w. Okay, let's say your z will be 4x. Okay, your z will be 4x. Then your w will be
For W.
This one is Z. So your W will be, if this sine Z is W, sine Z is W now, so your Y will be not W. So this is extended chain rule. So how we get the so we have Y, okay, Y we have W. W we have Z. Z we have X. So to get this dy dx, it will be dy dw,
DW, DZ,
dw dz,
DZ,
and dz dx. Okay? This is dy dw, y dw, dw dz, and dz dx. Okay, this is dy dx. Okay, so dy dw, dy dw, 1 over w, dw dz, cos z, dz dx, 4. So you have a 4 times cos z, z is 4x over w, w is sine z, where your z is 4x. You get the same thing. This one, because we all know that how to differentiate this one to get the dw dx. Okay, so we can save one step. Okay, but question number 5. Okay, question number 5, I want you to use extended chain rule. Extended chain rule for number 5. Z, what is your Z? Huh? Your Z should be, what is the innermost function? X squared minus 3x plus 5. This is your Z. Okay. So your W will be square root Z. Okay. Then your Y will be, yes. Okay. So dy dx will be a y dyd w, and then dw dz, and dz dx. Done? dw dy dw. dw, right? dw dz. dw dz. This is z from us. Okay, so dw dz, when we differentiate this, you get a 1/2 z, and then half minus 1. Negative half. Okay, dz dx, you have 2x minus 3 in the bracket, 2x minus 3. Okay, simplify. So we have at the top, we have 2x minus 3. Okay, this one at the bottom, this one also at the bottom. Okay, we have e to the power of w. W is z, where z is this. Over the 2, and this is z. Okay, negative mean, again, negative mean is stay at the bottom. So we have z to the power of half. Z to the power of half means third of z, where z is this one. Okay, so if you didn't see this, okay, you can make one more line. You can have this one over 2, and then this is z, and then EW. Okay, you can write this one before this. Oh. Number 6. Need to use extended chain rule. Extended chain rule. If you use chain rule, you get the same answer. Okay, done. Okay, last one.
Satu tolak tiga.
Okay, this one, Anna. The Z is
1 minus 3x.
1 minus 3x. W is,
Okay, only.
if W equals to Z only, then we don't need extended chain rule. Your W should be cos
Cos Z. Cos Z turunan Z.
cos Z. Cos Z. What is your Y?
Plus 2W.
2 cos 2W.
What is Y?
W is square.
W squared. Okay, what is this? Cos squared. Cos squared means cos 1 minus 3x squared. The square here means this. Okay, so dy dx is dy dw, dw over dz and dz over dx. Okay, dy dw, dw dz dz dx. So you get a positive 6w sine z. Positive 6w sine z. Okay, and we change the w and z back into x. W is cos z. Cos where z is 1 minus 3x. And then sine z. Okay. Online ini. Halaman, halaman. Yang children. Yang answers. Anak main.
Belum lagi.